Uh, my name is Vansh. Today we'll discuss about the ClickHouse databases, what these are, and how that can help us to build applications or which type of application it is more helpful than the generic one. So let's get into it. So what is database? Uh, it's not like SQL or SQL databases or MongoDB like these these databases are for generic use. Like if you want to build an application, let's suppose a chat application, you need to store some chats, some calls. Then you should use SQL or MongoDB. These or Postgre, these type of databases, right? And and when you are building like observability platform, analytics platform, है ना? Where you need to search upon key what is the average of all the watch time and uh, error percentage, है ना? Which time which time my application dies, which isn't available, availability percentage, things like these. When you are building observability or analytics platform, then you need ClickHouse DBs because these are uh, fast for these kind of application. I'll tell you why these are fast. So let's get into it. High performance OLAP database. OLAP database is nothing just what store data in columns instead of rows. If you see MongoDB or SQL, it stores data uh, a row by row, right? Okay, this is this is the ID and this is the name of the person. There's some metadata and things like this. And if you and OLAP databases use store columns instead. Okay, let's suppose if you uh, want the average of the uh, today watch time. Okay, just okay, let's suppose you are building YouTube, right? And you ask to your engineer ki find out the average watch time today, right? So then you need to go through multiple rows. Okay, yeah, and mm, uh, in that row, multiple columns isn't needed. Like name, I don't care. User email, don't care. है ना? So I just need an watch time key and its value for every user. Like today's what is ClickHouse? It's an column-based database that stores data in columns instead of rows. Open source columnar database. It's an open source. You can go through its code directly. So design it for OLAP analysis. Just I just tell you what is OLAP. Right, optimized for billions of rows key. Yeah, I create one. All right. Mm, oh fuck, you didn't see my screen, right? I'll just take it in. There you go. This. Yes. Yes. I was just talking about ClickHouse database and what is OLAP database is. Right. Next, what is ClickHouse and these things. I'll tell you how it is stored as a column instead of rows. I'll just go to an accelerator. Let it. Let's suppose this is our DB, right? And it stores things like it's in simple DB, right? Let's MongoDB, yeah, we can say, or Postgre, uh, Post, mm, right? And it store things like this the ID. Should I? Yes, uh, this is the ID. What happened? Sorry, guys. Let's suppose this is the ID. This is the name of the person, and it's an email, one shared the gmail.com, and some mm, watch time. That's mm, some other metadata, right? And there are multiple roles. Suppose these are separate users. I'll just yeah, these are separate. How SQL or MongoDB stores key things like row by row. It is in separate row. This is in separate row. Things like this. And how ClickHouse DB stores data. Things like uh, instead of row by row, it stores data like this is the name column. Understood, right? Okay, this is the name column. This is the email column, and this is the watch time. Things like this. And suppose if we need to find out the average of the watch time, then here I need to go one by one. Here. Then calculate each of the watch time, right? And the name, email didn't care, doesn't care for me. I don't want to I don't want to use that, right? I just want a watch time. So here I need to load all the things. Uh, SQL needs to read uh, all the rows and it's all the columns, right? And here, if I need to give me the average of watch time, I'll just go through this column and that's it. Because these are separately stored. I hope instead the next noised for billions of rows. Yeah, these can be multiple. Okay, but, rows. 100 billion, right? And if I go through only the watch time column, it's cost me less CPU instead of this approach, right? Optimize for billions of rows, done. Why? Done fast aggregation because I just need to go through only that row. Or if I only want to give me uh, here we are here you only need an column. Let's suppose we need only two columns, then the same approach can work, right? Fast aggregation done by done. The next is why ClickHouse. Millisecond analysis, the same thing. I just need to go through n column or the related column. That's it. High compression. High compression means, see, if I use, let's suppose, one thing more. Okay. Uh, let's suppose country. Uh, India. Then all the users are here are from India, right? And each row stores India separately, right? Here, if I store and mm, that there will be the separate column for India. Let's suppose all the rows are containing the city, right? Uh, yes, all the rows are containing cities. So if you see, India is repeatedly stored. Key here, India, 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 India. Too many, and we can compress that instead of storing all the Indias. Just like here, these are the fives. Key, uh, India into five. Then I don't need to store India 5 times or the 100 times. If right, so I'll just store things like this. This is an compression, high compression, things like this. Parallel execution. Uh, if we use uh, single threaded databases, then what it uses, okay, run one by one. I only have a thread that is processing each row one by one. And it uses parallel execution. Let's suppose if we have eight CPUs or eight threads, then my work can be divided into parts and then they will handle execution of all the parts, and in the end we'll just add all the results into it. Like key, I just want to uh, search on all the one, will suppose 10 million rows. I just need to read 10 million rows. So it use parallel execution. Like if we have four CPUs, then it divided the work into parts. Let's suppose five CPUs. First, what first CPU do is key 1 to 2 million. Second CPU do is 3, 4 million. And same key 3 to 4, 5 to 6. And in the end, 9 to 10. And here will merge all the results. Like so, if I just have one CPU, it will cost around like let's go 10 seconds. Here we have 5 CPUs. Then I just need it will all the calculation it will happen in just 2 seconds, right? Mm, Scales to TB, terabyte, petabyte databases. Here are load of rows, you know, like like we are storing logs, things like these. Orthan columnar storage stores data as in column, store data by columns, reads only required column. I just said you key. I just want watch time, then it don't need to read uh, name column and the email column. Lower disk input output because I just uh, I'm just going to read this column, so I don't need to load these columns into while reading, right? Better compression than uh, things like this one, right? The next is indexes. Huh? How we index some keys into the simple databases. Let's suppose we add an index on name and then it creates an B tree. And if I want to search on any name, then it will figure out in Logan or something like here. It's building B tree, but we cannot build B tree here because uh, mm, why we cannot build B tree here? Mm, Because all the columns are separate, so they are separately stored. First thing, and if we want to search upon, let's suppose, ID number 250, 50, I get the ID. I cannot directly get all the columns of it, right? So B-tree won't help here. And here we index, here index store like key into store data in batches. Batches like 1 to 100 IDs in first batch. 101 to 500 IDs in second batch, things like this. And I'll just go through if I need to search on 250, it's 200 by the way, 200 and 201 to 300, things like these. And if I want to search on 250 ID, then I'll just first I ask to first batch. For, basically, if internally ask to first batch, is the 250 ID stored in your batch? Then first batch said, you know, uh, I only have minimum is one and maximum ID is 100. Okay, I'll go to the next one. Then it asks to the second batch the same thing. Okay, is the 250 ID is stored in yours batch? Then it also said ki I have minimum 101 and the maximum 200. Then it asked to the it said no. Then it asked to the third batch ki if 250 ID is stored in yours batch, then it said ki I have minimum 201 and the maximum 300. Then it figured it out. Maybe 250 ID can store in the third batch. Then it just go through the third batch. It didn't don't need to read all the batches, all the data, right? Things like these we store use indexes here, sparse parameters. These are the some indexes types, and if it create a large video, then we can discuss all these separately. And the next is compression. We discussed about it. To store things like this, so it don't need to store the same thing again and again. Compresses each column independently. Yes. Saves storage. Yes. Reduces input output. Yes, because I just need to read this one instead of the 5 time right India. Speed up queries because speed up queries the same thing. Okay. If I don't need to read India multiple times, I don't need to read India multiple times. I just need this. Then I'll just figure it out what it is. Speed up queries done. Scaling. Huh. Ooh, okay. How scaling is different uh, from the simple databases. Uh, okay, okay. There are two ways of scaling. Uh, we can store all the columns into the separate DBs. Like key, if we have millions of rows or billions of rows, we can store a name column in a separate DB and email column in separate DB, watch time separate DB, things like these. And the second thing is we store into batches, okay, 1 to 100, okay, 1 to 1 million rows in first DB and 1 million to 2 million into the second DB, things like this. Scaling done, and this is by the way, yeah, it is the sharding part, right? And the replication is same as the simple DB key. We store same thing into the separate DB for the high availability, right? And these are the things. Okay, if you wanna go deep dive into it, then just read things like these. Sharding, we discussed our sharding. Sharding, split data across servers, more storage, higher throughput, high availability. Sorry, high availability here. Okay. If I have load of data, I can split the data across servers. Then I just uh, keep, yeah, 1 to 1 million into the separate DB and million to 2 million in separate DB. Applications we store the same thing again into the another DB so that high availability can be increased, or the my if my primary DB crashes crash, and then I can uh, res backup that from the replication DB. So multiple copies of data, high availability, fault tolerance key. If one dies, this it can get the data from the another DB. That's the simple part. When to use, when not to use. Use if you are building applications like analytics, logs, time series, observability platform, the, the log platform which stores logs, or the observe the application part like watch watch time is also into analytics, right? Avoid OLTP. OLTP is just this simple application like chat app, uh, polling app, or photos app, things like this. Where we need frequent updates, then don't use the ClickHouse DB. Complex transactions, okay, a payment tab, like this. Then here you should use Postgre or MongoDB, things like these. Here you should use ClickHouse and DBs, right? Use cases, observability, things like these applications. The next summary first, OLAP DB. Well, it stores data in columns, columnar storage, compress, all the columns can be compressed if the similar thing is happening again and again. Scalable, we can store uh, each column into separate DB. Idle for analytics, yes. Because if we just need to go through an column for all the rows, we just need to read that column. And if that is separately stored, I just go through it and don't need to see another columns of that row. Right? Done. I think this is the brief. All right. Bye bye.